Matter and its construction. Lesson 1. Matter and its characteristics, or we can say matter and its properties. First of all, we have to know what's meant by matter. Matter, it is everything that has mass and volume. Or we have another definition, it is anything that has a mass and occupies a space. The word occupies a space is the definition for volume, so the two definitions are the same. As you can see, everything around us is matter. Book, pens, pencils, water, air, even living beings, because they have mass and they have volume. Let's talk about properties of matter. Properties of matter are classified into two categories, into two groups, which are physical properties of matter and chemical properties of matter. We will talk about some of the physical properties of matter, such as color, taste and smell, density, melting point, boiling point, hardness, electric conductivity, and finally thermal conductivity. Let's talk about color, taste and smell. We can use the color property to distinguish or to differentiate between gold, silver and iron, because they have different colors. Also, we can use the taste property to differentiate or distinguish between salt, sugar and flour. Finally, we can use the smell property to differentiate between perfume and vinegar, because they have different odors. Let's talk about the second physical property, which is density. Before we can find a definition for density, we have to know the definition of two other concepts. The first one is mass. Mass, it is the amount of matter that the body contains. Mass is measured in kilogram or gram. Mass is measured by using sensitive balance. The second concept is volume. Volume, it is the space that a substance occupies. Volume is measured by cubic centimeter or milliliter. Volume can be measured by using graduated cylinder. Now we can find the definition of density. Density, it is the mass of unit volume of matter, or it is the mass of 1 cubic centimeter of matter. As you can see, unit volume is the same as 1 cubic centimeter of matter, because the measuring unit of volume is cubic centimeter and unit means 1. The measuring unit of density is gram per cubic centimeter. And the mathematical relation that we will use to calculate density is density equal mass over volume. And the number that we will get from this calculation will be in gram per cubic centimeter. If you want to find the volume, volume is equal to mass over density, and the unit is cubic centimeter. For mass, mass equals density times volume, and the unit will be gram. For density, we will use the small unit, gram for mass, cubic centimeter for volume, so the measuring unit for density will be gram per cubic centimeter. We have a question here. What's meant by the density of iron is 7.8 gram per cubic centimeter? To answer this question, all we have to write is the definition of density. This means that the density of 1 cubic centimeter of iron equals 7.8 gram. If we want to explain it more, if suppose that we have cubic box made of iron, if its volume is 1 cubic centimeter, so its mass will be 7.8 gram. This is because its density is 7.8 gram per cubic centimeter. Another question, give reasons for. Equal volumes of different substances have different masses. This is because they have different densities. Each matter has its own density. So if we have equal volumes like that we have here, we have three different substances. The first cube is made of iron, the second one is made of copper, the third one is made of cork. As you can see, they have the same volume, 1 cubic centimeter, but they have different masses. This is because they have different densities, because they are different substances. As you can see, if we started the statement with the word equal volumes, we will end it with different masses if we are talking about different substances. The second question: equal masses of different substances have different volumes. The same, but we started with equal masses instead of equal volumes in the last question, because they have different densities. The same three substances, iron, copper and cork, but at this time they have the same mass, 1 gram. As a result, they have different volumes. This is because they have different densities, because they are different substances. Let's solve some problems about density. The question is, what is the density of 70 grams of a substance that occupies 50 cubic centimeters? To solve any problem, we have first to write given. Our givens in this case is mass is 70 grams. We know this number is related to mass because its measuring unit is gram. Of a substance occupies 50 cubic centimeters, so this is the volume and density is unknown. The second step is to write down the rule. We are talking about density, so we will put our hand over density, so it is equal to mass over volume. By substituting for each unknown, 70 over 50, this will be equal to 1.4 gram per cubic centimeter. The second idea about density: on determining copper density using a piece of copper of mass 88 gram, this is the mass of copper. The piece is immersed in 100 cubic centimeter of water, so this is the volume of water. The water increases up to 110 cubic centimeter. This is the volume of water and copper together. Find the density of copper. Given mass of copper is 88 gram, volume 1, which is the volume of water, is 100 cubic centimeter. Volume 2, which is the volume of copper and water, is 110 cubic centimeter. Density of copper is unknown. By using the rule, we want to find density. Density equal mass over volume. But because here we have two volumes and we need only to find the volume of copper only, so we will subtract the two volumes. Mass over volume 2 minus volume 1. 88 over 110 minus 100 equals 88 over 10 equals 8.8 gram per cubic centimeter. This is the volume of copper. Problem 3. In an experiment for determining the density of a liquid, the following results are recorded. The mass of an empty beaker equals 75 gram. The mass of the beaker containing liquid equals 135 gram. The volume of the liquid equals 100 cubic centimeter. Calculate the density of the liquid. As you can see here, we have two masses, while in the previous problem we have two volumes. I think you know what we have to do in this problem. Given mass 1, which is the mass of the empty beaker, equals 78 gram. Mass 2, which is the mass of the beaker and liquid, equals 135 gram. Volume of the liquid equals 100 cubic centimeter and density is unknown. By writing down the mathematical relation, now we have mass 2 minus mass 1 over volume. This is because we have two masses and we want to find the mass of the liquid only. equals 135 minus 75 over 100 equals 60 over 100 equals 0.6 gram per cubic centimeter. This is the density of liquid. We have a live application for density, which is the same question as sink or float. And we have to do this activity. As you can see, we have a piece of food. Its mass is 2 kilograms. As you can see, before putting it in this container, the volume of this liquid is 100 liters. After adding it, the volume increased to 102, but the piece of food must be totally immersed under water to find its volume. As you can see, the final volume is 105. This means that the volume of this piece of food is 5 liters. By dividing its mass, which is 2, over its volume, which is 5, we will find that its density is 0.4, as you can see here. And you know that the density of water is 1. This is because the mass of water is always equal to its volume. And as you can see, the density of this piece of food is less than the density of water, so it will float. Let's have another substance. Ice. As you can see, the mass of this piece of ice is 4.6 grams and the volume of liquid is 100 liters. By putting it and submerging it totally, you will find that the volume increased to 105. So the volume of this piece of ice is 5. By dividing 4.6, which is mass, over 5, which is volume, you will find that the density of ice is 0.92, which is still less than the density of water, so ice will float because its density is less than the density of water. Let's have a piece of brick. As you can see, the mass of this piece is 10 kilograms. The starting volume, or V1, is 100 and its volume plus the liquid is 105, so its volume is 5. By dividing 10 kilograms over 5, so its density will be 2 grams per cubic centimeter or 2 kilograms per liter, which is more than the density of water, so it will sink. Let's have a piece of aluminum. Its mass is 13.5. V1 is 100. After putting it, its volume increased to 105, so the volume of this piece is 5. By dividing 13.5 over 5, we will find that the density of aluminum is 2.7, which is still more than the density of water, so it will sink, as you can see. What about having pieces which have the same mass? As you can see, all of them, their mass is 5 kilograms. Although they have the same mass, they have different volumes. And we answered this question before. As you can see, these two pieces sink, while this piece only float. This is because they have different densities. What about having the same volume? These 4 cubes have the same volume, but as you can see, they have different masses. This is because they have different densities. Some of them sink, some of them float. What about materials which have the same density? To have the same density, they must have different masses and different volumes. They have the same density, but they have different masses and different volumes. What about having 5 unknown cubes? We don't know their density. Can we find their densities? Yes, we have a balance scale. Let's start with cube A. Let's find its mass. Its mass is 65.14. Its volume is V1 is 100 and its volume is 3.38. By dividing 65 over 3.38, we will find that its density is more than the density of water, and we can find it, so it will sink. What about QB? Its mass is 0.64. Volume 1 is 100. Volume 2 is 0.64. By dividing its mass, which is 0.64 divided 0.64, so its density is 1. This cube is water because the substance which its density is 1 is water. What about C? Its mass is 4.8 and its volume is 5.83. So its density is less than 1, so it will float, as you can see. What about D? Its mass is 3.10 or 1. Its volume is 3.38. Its density is still less than 1, so it will float. The final cube, E, its mass is 3.53. Its volume is 1. Its density is 3.53, so it will sink. If we have a table containing the density of different materials, we can determine the materials from which these cubes are made from. So this is an important method to identify the type of material that we are using. As you can see here, materials which have higher density than water sink in it, such as iron, nail, and metallic coin, which is made of copper. As you can see here, the density of water is 1 gram per cubic centimeter, and any material which has density less than the density of water, will float, while any material which has density more than the density of water, will sink in it. Less density, float; high density or higher density, sink. While other materials which have lower density than water float on its surface, such as wood, cork, ice, and drops of oil. Let's talk about some life applications for density in our daily life. Give reasons for. Water is not used to put out or extinguish petrol oil fires. This is because the density of petrol is less than that of water. So petrol will float on water surface, and water doesn't put out the fire. Life application 2. Balloons filled with hydrogen or helium rise up in air, carrying flags during festivals. This is because the density of hydrogen and helium are less than the density of air. As you can see, the density of air is too small, but densities of helium and hydrogen are much smaller. So if we have balloons filled with hydrogen and helium, they will rise up in air. The final life application for density. The determination of the change in the density of matter is taken as an evidence of the purity of matter, as determination of the quality of milk. The third physical property is melting point. What's meant by melting point? It is the temperature at which a matter begins to change from a solid state to a liquid state. And here we have to mention the word temperature at the beginning of our definition. So melting point, it is the temperature at which matter begins to change from solid state to a liquid state. What's meant by the melting process? It has the same definition without the word temperature. It is the change of matter from a solid state to liquid state. Let's have a question. What's meant by the melting point of ice is 0 degrees Celsius. This means that ice begins to change into water because ice is the solid state, water is the liquid state at 0 degrees Celsius, which is the melting point of ice. Note the following. Some solid substances have low melting point. This means that they will need small amount of heat to melt, to change from solid into liquid, such as wax, butter, and ice. As you can see, if we have a piece of ice at room temperature, it will melt quickly because ice has very low melting point, which is equal to 0 degrees Celsius. Some solid substances have high melting points. This means that they need huge amount of heat to melt, to change from solid into liquid, such as iron, copper, aluminum, and table salt. As you can see here, this is a melted aluminum. It took a huge heat energy to change from its solid state into this liquid state. What about applications of our melting point in our daily life? Using melting points to differentiate between three unknown metals. As we did in density, we use the density to differentiate between unknown materials and to identify them. Also, we can use melting points to identify three unknown metals, like in this video. As you can see, we have three unknown materials. We will start to heat them, and by using a special thermometer we can find its melting point. The melting point of the first substance is 327, which is the melting point of lead. So this smiley face is made of lead. The second substance begins to melt. Its melting point is 660, and by referring to chemistry reference we will find this substance is aluminum. This is the last object. By heating it strongly, it starts to melt. Its melting point is 1084, which is the melting point of copper. So melting point is very important to identify the type of material. Life application. We use melting point in the manufacture of alloy. We have three alloys in our syllabus. Gold copper alloy, which is made, as you can see from this video, from gold and copper. After melting gold and copper, they mix them together and they will leave them to cool down. They will form something called alloy, which is a mixture of two or more substances. In our case, it is a mixture of gold and copper. Gold copper alloy is used in making jewels, which is used for decoration. We have another alloy which is called nickel chrome, which is made of nickel and chromium elements, which is used in making heating coils. The third one is a stainless steel alloy, which is used in making cooking pans. The second application for melting point is it is used in the manufacture of cooking pans from aluminum or stainless steel. Why? This is because they have high melting point. The fourth property is boiling point. We will find a huge similarity between boiling point and melting point. What's meant by boiling point? It is the temperature at which a matter begins to change from liquid state to gaseous state. Temperature, liquid state, gaseous state. They are the key words. Boiling process. It is the change of matter from liquid state to gaseous state. What's meant by? The boiling point of water is 100 degrees Celsius. This means that water begins to boil into water vapor at 100 degrees Celsius. Water, which is the liquid state, water vapor, which is the gaseous state, and this is the boiling point. What about the life application for boiling point? The first one is the separation of the component of petroleum oil depends on the difference between them in their properties. We have a sample of petroleum oil. By heating it strongly, some parts of it will change into gaseous state at certain boiling point. By collecting them and by cooling them down, they will change back into liquid. As you can see, we have the first component, which is colorless. By continuing heating, after a short period of time, another component will start to boil and change into the gaseous state from this oil mixture. By collecting it again and by cooling it down, it will change into liquid state. As you can see in this, it is yellow. By continuing heating again and again, we will have the different components which are forming the petroleum oil. This is a great application for different melting points. So by using different boiling points, we can separate the components of petroleum oil because each component has its own boiling point, the temperature at which it will change from the liquid state into the gaseous state. Then it will be collected and cooled down so it will change back to the liquid state. The second life application is boiling point depends on the pressure. Whereas the pressure increases, boiling point increases. We can boil water at room temperature. Yes, we can do this. This is true. By changing the pressure. In the beginning of this video, we have a compressor. By changing the pressure, although the temperature of water is still at room temperature, which is 21 degrees Celsius, it starts to boil. So we can increase or decrease the boiling point of a substance by changing its pressure, because boiling point depends on pressure. The fifth property is hardness. In hardness, we will talk about 3 points only. We will say the first one, some solid substances are soft at room temperature, such as rubber. As you can see, a piece of rubber is soft. You can stretch it. So some materials or some solids are soft, such as rubber at room temperature. The second point is some solid substances need heat to become soft and easy to be shaped, such as metals. As you can see here from this video, this is a very hard metal, but we can reshape it if it is heated. So some solid need heat to become soft and to be shaped as metals. The final point, some solid substances don't melt by heating, such as coal and sulfur. They will change into ash, but they will not melt. Life applications for hardness in our daily life. The screwdrivers, this one, are made of steel iron. The screwdrivers are made of steel iron because it is very hard. The rods used in building houses, concrete, are made of iron, not copper. Iron rods, copper rods. This one, which is used in building houses, concrete. This is because the hardness of iron is more than that of copper. The sixth property is electric conductivity. Substances can be classified according to electric conductivity into two categories, which are good conductors of electricity, which are called good conductors, and bad conductors of electricity, which are called electric insulators. What's meant by good conductors of electricity? They are substances which allow electricity to flow through. Bad conductor, the same definition, but by adding don't. They are substances which don't allow electricity to flow through. Examples: acidic solutions and alkaline solutions are good conductors of electricity. Acidic solutions, they are liquids which change the color of litmus paper into red, and alkaline solutions, they are substances which change the color of litmus paper into blue. Both of them are good conductor of electricity. Some salt solutions are good conductor of electricity. Metals such as iron, silver, copper, and aluminum are good conductors of electricity. Examples for bad conductors of electricity: gases. All gases around us are bad conductors of electricity. Some solutions are bad conductors of electricity, such as sugar solution. Sugary solution is sugar dissolved in water, is a bad conductor of electricity. So sugary solution is bad conductor. Some salt solutions are good conductors of electricity. Solutions of hydrogen chloride in benzene is a bad conductor of electricity. Some solid elements such as sulfur and phosphorus are bad conductors of electricity. Let's talk about life applications for electric conductivity in our daily life. Electric wires or cables are made of copper or aluminum and covered by a plastic layer. As you can see, we have two parts in this question. Why electric wires are made of copper and aluminum? This is the first part. And why it is covered with a plastic layer? This is the second part. Because both of copper and aluminum are good conductors of electricity. So we answered the first part. While plastic is a bad conductor of electricity. And this is the answer of the second part. Copper, aluminum. The second life application for electric conductivity: screwdrivers are made of steel iron. This is the first part, while their handles are made of wood or plastic, and this is the second part. The first part, because steel iron is a good conductor of electricity and it has a higher hardness, but wood and plastic are bad conductors of electricity. So we answer the first and second parts of our question. The seventh property is thermal conductivity. Substances can be classified according to thermal or heat conductivity into two categories: good conductors of heat, bad conductors of heat. We will use the same definition that we used in electric conductivity. Good conductors of heat, they are substances that allow heat to flow through. Bad conductors, they are substances that don't allow heat to flow through. Examples for good conductors: metals such as iron, copper, and aluminum. Bad conductors such as wood and plastic. Life application 1 for thermal conductivity: cooking pans are made of aluminum. This is because aluminum is a good conductor of heat. Also, it has a high melting point. Life application number 2: handles of cooking pans are made of wood or plastic. This is because wood and plastic are bad conductors of heat. Now we finished physical properties. Let's talk about the second category, which is chemical properties of matter. Metals can be classified according to their chemical activity into three groups: very active metals, less active metals, and finally inactive metals. Let's start with very active metals. What's meant by very active metals? They are metals which react with oxygen as soon as being exposed to humid air. Humid air means air plus water vapor. So they lose their metallic luster. They will not be shiny. A layer of rust will be formed on them as a result of their reaction with oxygen. Any metal reacts with oxygen, a layer of rust is formed, which is the metal oxide. Metal oxide is a compound resulted from the reaction between metal and oxygen. Examples for very active metals such as sodium and potassium. This is a piece of sodium. If we remove its outer layer, we will see that it is very shiny. It has a wonderful metallic luster, but as you can see, this metallic luster, as soon as is being lost due to its reaction with oxygen. This is a piece of potassium. Its reaction with oxygen is faster than that of sodium. They are very active metals. As you can see, they will react with water strongly. This is a piece of sodium. This is a piece of potassium. Its reaction with water is very strong. And a hydrogen gas is evolved, which is burned with a pop sound. As you can see, this is the strength of this reaction. These metals are very active metals. Life application for very active metals give reason for sodium and potassium, which are examples for very active metals, are kept under kerosene surface. Why? This is to prevent the reaction with atmospheric oxygen, because as you saw from the last video, they react strongly with atmospheric oxygen and with water. So they are kept under kerosene surface to prevent their reactions with atmospheric oxygen. What's meant by less active metals? They are metals which react with oxygen, like very active metals, but if left in air for some days and a layer of rust is formed. So they react with oxygen but slowly. They react slower than very active metals. Examples: iron, aluminum, and copper. Life application for less active metals give reasons for: steel bridges and holders of light bulbs are painted from time to time. Metallic spare parts of cars are covered with grease. The two questions have the same answer: to protect them from rust and corrosion. To protect them from rust and corrosion. Washing of cooking pans made of aluminum with a rough material. This is to remove any layer formed on them. The final type of metal is inactive metals. What's meant by inactive metals? They are metals which find great difficulty to react with oxygen. They don't react with oxygen under normal conditions. Examples: silver, gold, platinum, nickel, chromium. Life application 1 for inactive metals give reasons for: silver and gold are used in making jewels. This is because they are chemically poor active or inactive, so they don't rust. Life application number 2 give reason for: nickel, gold, and silver are used to cover other substances which rapidly means quickly, gain rust, to protect them from corrosion. Thanks for watching. This is the end of lesson 1.